Okay, we're going to look at question number 4 now. We're going to find the velocity function given the position function. So our position function here is t cubed minus 4t squared plus 3, and the time is greater than or equal to 0. So velocity again is the derivative of t cubed minus 4t squared plus 3, which would be 3t squared minus 8t. So we can look at this as s prime t or v of t. Here's your velocity function. And what we're supposed to do with this, again, is we're supposed to perform sign analysis on that first derivative, whichever one you want to look at. It's the same derivative. So we have to do sign analysis here. Okay, sign analysis on that first derivative. So we're going to look at this function here, and remember the first step is to set that function equal to 0 because it's a polynomial function. It's not rational, but either case we set it equal to 0. And now we're going to solve for t here. And solving for t, we're going to factor. We're going to use the greatest common factor. I don't know what happened there, but all right. So here we go. Looks like t comes out only, and you're left with 3t minus 8 equals 0. We got to solve this for t. And solving for t now, you use the zero product rule. This means t is 0, or 3t minus 8 is 0. So we're going to solve for t. 3t is 8. Divide both sides by 3. And now you get t is 8/3 here. Okay. So we have what we need. We have a real number line. This is over the first derivative. And it happens at t is 0, we get 0. And at t is 8/3, we have a 0 for the velocity. And we can look at it this way. This is region 1, region 2, region 3, if we're looking strictly at the sign analysis process. T, again, is positive. So let's go back and remember, we're going to check the sign here of this function. But the t values are positive. Actually greater than or equal to 0. So it means quadrant 1 is thrown out because these are t values that are to the left of 0. And I recommend using in sign analysis the factored form. You guys will see how that can be actually beneficial. So for the sign analysis procedure again, we need to test the signs of each region. Really testing the sign of region 2 and region 3, we need test points. So 1 is available. I'm going to use that as a test point. And then 8/3, we're going to use, is less than 9/3, which is 3. So we got our test point values, 1 and 3. We're going to test the sign of the region by plugging in 1. which gives us 1 times, really 3 times 1, which is 3, minus 8, which really this is just 3 minus 8. I guess we don't need the parentheses. And that's going to be a negative 5. Now, we only care about the sign here, so region 2 is negative. This is how we perform sign analysis. When we test region 3 using that test point of 3 here in the sign analysis procedure, we're going to try to find the sign, which is 3 times 3 minus 8, or 3 times 9 minus 8. It's 3 times 1, which is 3. The point is this is positive here. Okay? Now, okay, here's the sign analysis we're supposed to do. Now, remember this is sign analysis, but remember what they want to know with motion. They want to know, when does the particle stop? Well, it stops when your velocity is 0. And that happens when t is 0 and t is 8/3. Those are in seconds now. Okay? This is where your velocity is 0, when t is 0 seconds and t is 8/3 seconds, because this is the whole purpose of us finding those values in sign analysis. Now, your particle moves to the right. We'll say it'll move to the right when the velocity is strictly positive. That's why you write greater than 0. The velocity is positive here in region 3. So we want to know, what is that region? Well, that's for time values that are greater than 8/3. That's an open interval. So I'll write it as an interval notation. It goes from 8/3 up to infinity, but we have it described as t being bigger than 8/3. So if t is bigger than 8/3 here, the particle is going to move to the right, and that's the analysis they want us to discuss. Moves to the right for t values greater than 8/3. We'll move to the left now. When velocity is negative. So this is why we did sign analysis again, because region 2, your velocity is negative. Remember, this is at s prime t. We check the signs of that. And the interval notation is going to be from 0 to 8/3. Now, what does that mean in terms of t? We said, okay, t is going to be between 0 and 8/3. So we say 0 less than t less than 8/3 seconds. And this is where your particle will move to the left now. So this is the conclusion for question 4. This is why you did sign analysis on that first derivative. This is describing motion, direction, left, right. When does it stop? And that's what you're looking at for number 4. Okay. We're going to repeat the process for number 5 here. We're going to look at sign analysis on the first derivative, which is the derivative of really the position function, s of t. S of t here is 5t cubed minus 4t squared plus 7 for t values greater than or equal to 0. So we need that derivative again, which is your velocity, s prime t. So let's go through this process. All right. So velocity which is s prime t, which is the derivative of your position function, which is 5t cubed minus 4t squared plus 7, which becomes 15t squared minus 8t. So we can write that as s prime t or velocity, v of t, doesn't matter. We got the derivative. Now, the sign analysis portion. This is what this looks like. We set the velocity equal to 0 and solve for t. So that would be 15t squared minus 8t equals 0. We got to solve for t now. So this is beginning algebra, and the only way you can solve for t here is by factoring out your t. Then you have 15t minus 8 equals 0. You get t is 0. And 15t minus 8 is 0. We're using the zero product rule. I didn't do this prior, but I want to share that with you guys in case you need to review that. The first solution is done, t is 0, and then the second solution, we got to solve for t. So that would be 15t is 8 by adding 8 to both sides. Now divide both sides by 15. Reduce your fraction if you can. I don't think you can. You're done with that. This is the second time value where your velocity is 0. This is in seconds. In seconds again, let's write it this way, seconds. All right. Notice something here I didn't share with you guys, but these are the t values also where you got these horizontal tangents here. If I can do that, I didn't share with you guys that in the other picture. Okay. This is where t is 0 down here, and I guess this other is going to be, what is that? 8/15 now. Right? So the derivative of the function, this is your s function. Like over here, just to kind of remark, at 0 and 8/3, right? So in this function here, this is s again. This is where t is 0. And it looks like over here is where 8/3 will be. So I just want to kind of go back and give you a little bit of the geometry and how that relates to something you already know and have done. These are the horizontal tangent locations where your derivative at those values of t is 0. So we just want to go back and remind people, horizontal tangents, it's all fitting together. You'll see it over and over again, but all right. Back to our sign analysis. Okay, so we'll draw the real number line, and we'll remember that here's where t is 0. Here's where t is 8/3 for the velocity function. I hate that. Sorry, you guys. I just don't like that weird line. This is where that derivative was 0. And again, you partition the real number line into 3 regions like we've been doing. Come on, seconds, move over there. And we go, okay, here's region 1, region 2, region 3. Your derivative, which we'll test the signs for, is this function, if we can bring it. Okay. But remember, t is greater than or equal to 0. That means we have to throw out region 1. We just need to test region 2 and region 3. So we need test points. And again, 8/3, 8/15, that's, I said there's a little deja vu there, but it's not 8/3. It looks like it's 8/15 here. Okay, that means my first test point, I have number 1 available again as a test point. Yeah, let me check something. Yep, number 1's available. Okay. All right. And what's bigger than 8/15? The number 2. That's available in region 3. So we're going to test the signs of region 2 and region 3. But like I mentioned before, I think that the factored version of your polynomial is a lot easier to do the arithmetic with in terms of using your test points. So for the first question, this is 1. 15 times 1 minus 8. This is just going to give us a 15 minus 8, which is about a positive 7. So region 2 is positive. The particle is moving to the right for values of t in region 2. Consider the test point now of the value 2. So we're going to plug in 2 wherever there's a t. This is sign analysis. This is 2 times 15 times 2 minus 8, which is 2 times 30 minus 8, which is 2 times 22. We get 44. So it looks like, ladies and gentlemen, region 3 is also positive. Okay. I don't think we've done anything wrong so far. Actually, we made a mistake. Yes, we did make a mistake. We can't use 1 as a test point, so there is a mistake. I went back. This region, remember, 8/15 is actually smaller than 1. So let's use 8/15. Let's use 1/4. So we made a mistake on that. Okay, that's barely smaller than 8/15. That might not even be that. So let's actually use something very small like 1/10. I think that is definitely smaller than the 8/15. We made a mistake. Let's fix this. 1/10. Okay. And we can do that. Plug in 1/10 now. Wherever there's a t, you get 1/10. 15/10 minus 8, which is 1/10. 15/10 minus 80/10. And that'll be a 1/10 times a negative 65/10. So this answer is negative. I know it's negative 65 over 100, but I don't care about the value. I care about the sign. It's positive times a negative. So this would be a negative answer right in here. Particles moving to the right. Particles moving to the left. Particle stops at 0. So now we have all the sign analysis information we need here, ladies and gentlemen. Let's get rid of the arithmetic. You got a video, you can rewind it, you can take a look at that. We're just going to now look at the solution here. Okay, I'll even get rid of the factored version, but they want to know, when has the particle stopped? Well, the particle stops again when the velocity of the function equals 0. That happens when t is 0 seconds, and that happens when t is 8/15. These are in seconds. Okay. There we go. The particle moves to the right when that velocity function is positive. And that's in green over here. So you're moving to the right for t values. Let's take a look. I like to see the interval. That's open circle because you don't include the 0. Okay, we don't include the 0. That's from 8/15 forever to the right there. So as interval notation, that will be 8/15, comma, infinity. In terms of t, we just say t is bigger than 8/15. So for the time being bigger than 8/15, you'll be moving to the right. You're going to move to the left now. When that derivative is negative. Now, where is that derivative negative? Right in here. For t values between 0 and 8/15. So 0 up to 8/15 in terms of interval notation, that means your t is between 0 and 8/15. This is the time interval where your particle moves to the left, ladies and gentlemen. So there's your conclusion. I will send this to you all, and it's sign analysis on that first derivative. Okay.